In 2013, Chang'e 3, an unmanned lunar mission, touched down on the northern part of the Imbrium basin, one of the most prominent of the lava-filled impact basins visible from Earth. It was a beautiful landing site, said Bradley L. Jolliffe, Ph.D., the Scott Rudolph Professor of Earth and Planetary Sciences at Washington University in St. Louis, who is a participant in an educational collaboration that helped analyze Chang'e 3 mission data. The lander touched down on a smooth flood basalt plain next to a relatively fresh impact crater, now officially named the Ziwei crater, that had conveniently excavated bedrock from below the Regolith for the Yutu rover to study. Since the Apollo program ended, American lunar exploration has been conducted mainly from orbit. But orbital sensors primarily detect the regolith, the ground-up surface layer of fragmented rock, that blankets the Moon, and the regolith is typically mixed and difficult to interpret. Because Chang'e 3 landed on a comparatively young lava flow, the regolith layer was thin and not mixed with debris from elsewhere. Thus it closely resembled the composition of the underlying volcanic bedrock. This characteristic made the landing site an ideal location to compare in situ analysis with compositional information detected by orbiting satellites. We now have ground truth for our remote sensing, a well-characterized sample in a key location, Jolliffe said. We see the same signal from orbit in other places, so we now know that those other places probably have similar basalts. The basalts at the Chang'e 3 landing site also turned out to be unlike any returned by the Apollo and Luna sample return missions. The Moon, thought to have been created by the collision of a Mars-sized body with the Earth, began as a molten or partially molten body that separated as it cooled into a crust, mantle, and core. But the buildup of heat from the decay of radioactive elements in the interior then remelted parts of the mantle, which began to erupt onto the surface some 500 million years after the Moon's formation, pooling in impact craters and basins to form the Maria, most of which are on the side of the Moon facing the Earth.